Hi, it's Chris Kuzmal again, and this time we're going to be talking about code analysis. Now, what we mean by code analysis in the context of the APCSA test is to be able to articulate how many times a given line of code can run. In the simplest case here, for example, on line 12, we know that's going to be run one time, and we would say that the number of operations computed there is 1. Now, we might have several operations, such as we see from line 16 through line 19 here, but the number of times that these operations get executed is always the same, no matter what the conditions are for the running of the program. So it's always going to compute 3 times d, compute a cosine, compute a arc cosine, and then print a bunch of things out. But it's never going to do more or less than that. Now, it's possible to have a varying number of operations if you have some kind of input, such as you might gather the current time in milliseconds from the system using this library call here. And that's going to be a number that's going to be varying. And that's going to affect whether or not you do execute line 26 based on the conditional in the if statement on line 25, or you could do lines 29 and lines 30. Which would be the alternative. And so, of course, in some cases we'll do 2 operations. In some cases we'll do 1 operation, and that's a function of the input. It starts to get more interesting when we talk about the number of operations that is proportionate to some input. For example, we might read in a line of text from the screen, from the standard input, and then iterate through the length of that input string, possibly say, for example, converting the value to converting the string to a character array, accessing the character, implicitly converting that to a number, adding that to f. It's all very sophisticated things that actually by now, if you've watched all the videos, you should know about. But the time that it takes to do this is going to be proportionate to v.length here, because it's going to iterate, this loop is going to iterate v.length times. All right, so that's worth knowing. Keep that in mind. Sometimes, though, the number of operations is proportional to the log, often the log base 2 of some number. Here we have a very simple loop that does a relatively sophisticated thing. It takes that f that we got from before, converts it to an integer. It was a double precision number, and it continues to iterate as long as I is greater than 2, dividing I by 2 every time. So it keeps dividing I by 2 over, it does divide I by 2 over and over again, and it also divides d by 2, and it prints d. How many times does this loop iterate? The number of times this iterates is the floor of the log base 2 of f, or maybe 1 more or 1 less than that. That detail usually is not requested of you in an APCS test. The number of operations can also be proportional to the square of the size of the input. So, for example, here we have an input array AR whose size is 4, and we iterate through it, and each time we iterate through it, we iterate through it. In other words, we're iterating through the array every time we consider each element of the array. And so that means we iterate a total of 16 times. So we're going to print ops. Line 65 will print a 16. We set ops back to 0 and we consider another situation. This is identical. This is a doubly nested for loop, which is our first introduction to doubly nested loops. The purpose here is to just understand that the complexity of this operation, the number of times we iterate, is just the number of times this loop iterates times the number of times this loop iterates. And they both iterate the same number of times. And so it's going to be the square of that number, the length squared. And so ops, again, will count up to 16. The behavior of this loop and this loop ought to be identical, and they are. If I make one small change, this is a typical thing you'll have happen, I might change the starting point for the index into the array to be at the start of the outer loop's index, or 1 more than it, because I don't want to repeat or reuse a value. And that will cause a different number, called a triangle number, of operations to happen, which we'll discuss next time.